Hi, this is Adam from MakerState, and I'm here with the fourth webinar for the Maker Partnership Program. Right now we're going to talk about Scratch Basics, number 1, The Great Race. And this challenge should be pretty familiar to you from training, but we're just going to refresh on some of the context and other mechanisms that will be helpful for delivering this challenge and some ways to take this challenge further. Okay? So for this challenge, you need what you need for all your Scratch challenges: your charged computers, internet access, optionally your pre-printed Scratch blocks that you can use to introduce some of the programs in the Discover phase, your rubric, your parent report, which need to be printed out, one per student beforehand, and your design cycle poster with the magnets. And again, we really want to stress using this design cycle poster and the magnets to lead your students physically through these 3 stages of our challenge and really isolate the different skills and questions that arise in each of those 3 stages. Okay? And for these rubric and parent report here, again, those can all be found here in the STEM Collab, right under links to challenge materials. We have our full lesson plan, the Scratch project prototype, which is my version of this project, the rubric, and the challenge report. Okay, so those are all there for you in the STEM Collab. And then, again, your design cycle poster. Okay, so, and one more note. So at this point, you should definitely have Scratch accounts for your students. I included adding Scratch accounts for your students as part of the last challenge and talked about it in the last webinar a little bit. So if you missed that or you didn't get around to adding Scratch accounts for your students, make sure they have accounts so that they can save their work, as they're completing challenges. What we don't want is for students to program these projects and then not be able to save them, because then everyone gets upset, right? So make sure you have accounts, and if you need a refresher on how to create a classroom for your a Scratch class for your makerspace and add students, you can either go back to the last webinar or go to the Scratch Skills series that you have available in the STEM Collab and check out video number 10, which I will link below this video, just in case you need to see it. Okay, so those are the materials. As for our Discover section, here you have a sample of what you might write on your design cycle poster. And our STEM idea: how can we use Scratch to create exciting projects and learn the basics of computer science? So this is probably, for some of your students at least, going to be their first time making a project in Scratch. So your Discover phase is mostly going to be geared towards introducing the Scratch interface, the project editor, and talking about the different components of the project editor right here. Okay? So you can start with a open-ended or a think, pair, share discussion question: what is a computer program? And talk about what does it mean to deliver instructions to a computer, and what are the things that we want computers to do for us? Whether, in this case, we're going to be creating games that we like to play for entertainment, but obviously computers can do much more than that for us. And what does it mean to program a computer to actually do these things? Okay? And then you're going to start talking about the Scratch project editor. And that's when we're going to get to our keywords here. And these are the main components of the project editor. We have sprites, and sprites are all the characters or interactive objects that we're going to program and have be part of our projects. Our backdrops are our background images for our projects. Our scripts are the actual code that we're going to write. And our stage is the place where we see our project being built in real time, where we can kind of view it as we're building it. And you might optionally want to use some of your pre-printed Scratch blocks again to introduce some of the programs in this challenge. So one thing that might work out, or that you could do, would be to show your prototype, right? And maybe have 2 students play through it like so. And then, use some of your pre-printed Scratch blocks to pseudocode or paper prototype. Okay, what are some of the different things that are happening in this project? Oh, we have a when right arrow pressed, move 10 steps, or this if touching finish line, say I'm the winner, right? Those are all things that you can prototype using your pre-printed Scratch box. So you can do that to give your students an opportunity to think about what they're going to program before they actually sit down behind the computer. Okay? So let's go over to our Scratch. Let's go over to our project now and just talk about some of the general things that are happening here. So we have for our basic script, when right arrow pressed, move 10 steps. if touching the finish line or if touching sprite 2, then say I'm the champion. So that's a pretty straightforward script there. The things that we really want to emphasize, let's make this just a little bit bigger. Just on using these blocks, first of all, looking at the shapes of the blocks to know how and where to connect them together. We have these blocks that are kind of puzzle piece shaped, and then these other blocks that kind of fit inside each other, like this touching block. And so just understanding what are some of the different functions of blocks and types of blocks that we're going to use. Okay? Also, things like how this drop-down arrow can give us different options for selecting different options for a particular block, right? Both for the arrow key and for this touching block here, and also our ability to change or edit the information inside any of these blocks, right? Changing the thing that we're going to say or changing the amount of steps that a sprite's going to move. Those are all really important Scratch skills and Scratch ideas that you should make sure your students are comfortable with as they're building this. Another thing I'm just going to show one more time is this creating of the finish line here. And again, what we're going to do for this, I'm just going to do this a second time just to show you quickly. Taking a rectangle, choosing a fill color, choosing the filled rectangle down here on the right side of these two options, and then clicking and dragging to create my rectangle. Okay? Once you do that, you can use the grow and shrink tools to get it the right size, etc. Oops, it's a little too small, but I already have a good one, so I'm not going to worry about that right now. So those are the basics of building this Scratch project, and getting it to this stable point right here. Now let's talk about some ways that we can take this project a little bit further, okay? So one fun thing to do is to take this from being a 2-player game to being a 1-player game and automating one of our sprites. Instead of having a person controlling it, having the computer control it. So let's go to our penguin and think about how we can make this penguin move without pressing the key over and over, okay? And we're still going to have to use this move 10 steps block, so I'm going to isolate this. What we don't need is this when right arrow key pressed, because we're not going to use the arrows anymore. And instead, I'll replace it, or not replace it directly, but we're going to use a loop instead to move our sprite forward, or to repeat an action over and over. So instead of using the right arrow, we're going to use this forever loop and put that move 10 steps block inside there. And now our sprite will just forever move forward. And that's way too fast, as we can see. So what I'm going to do instead is take this down to about 3 steps every frame. And then I'm going to take this if-then statement and put it inside here. And then finally put a stop all block after that so that the sprite will stop moving once they reach the finish line, okay? And now let's try that. Very good, and we have the penguin moving, and now the cat tries to catch up, but the cat is still a little too slow. Let's make this 2 steps instead of 3 steps and try that one more time. Ooh, so we had a photo finish there. So one fun challenge that arises out of this is figuring out how we can make only one sprite announce their victory when they cross the finish line. And that's a challenge that takes a little more of a creative solution. And I'm not going to dive deep into it right now, but I'm curious to see if you or any of your students find a way to do that. It's a little bit tricky, but there are a few ways to do it. Okay, so there's one fun way to hack this project. Oops, stop that. Another thing we can do is add a referee. So I'm going to go to New Sprites and add just this bear here to kind of act as a referee for the race, and shrink the bear down a little bit. And maybe just have the bear say, on your mark, mark, get set, go. Okay, and so now when we run this, we'll have on your mark, get set, go. But first of all, that takes a really long time, so I'm just going to make these all 1 second. And then we need this penguin to actually wait for those 2 seconds until the bear says go. On your mark, get set, go. And now they're off. Okay, so without going too deep down the rabbit hole of how we can improve this project, there are some simple ideas that you can give to your students as prompts or use in your own prototype to enhance your project a little bit and take it beyond, you know, the basic just two-player race. And these are also things you can introduce during or after your play testing sessions, right? So after your students finish their basic build, we want to stop and do a full play testing section, which can be done either with in pairs or as more of a gallery walk, walking around. And we want students to write feedback down on either Post-its or a piece of paper so that they can save their feedback for their projects and read through it. And details on how to do this, again, are here inside the lesson plan. If we just open this up quickly. So you have more details for how to do that play testing session down here in the lesson plan, again under the improve phase. So here we talked about the gallery walk or the think, pair, share. So you can read through this and look through these guided questions for play testing if you have any need some more prompts on how to administer that play test. Okay, and then